Hello students, we are looking at number 2 on 4.8, the anti-differentiation, and I wrote down number 2 here. Before we can do this problem, we have to remember what we can take the antiderivative of: a power, 1 over x, e to the x, and all the trig functions here, and then antiderivatives of the inverse trig functions here. But the ones that we're looking at here are powers. So I'm going to rewrite this, and when I rewrite this, it's still f of x. And this is 5x to the negative second plus 6x to the negative 1 plus 3x to the negative 1/2. All right, so we've rewritten enough to take derivatives. Now we're rewriting to find antiderivatives. And I'm going to use the power of x. This is the one that gets used the most, unless you have a negative 1 power. Then it's your log, natural log. So here we go. I'm going to do capital F of x for my antiderivative. So make sure your notation is good. And then we're going to add 1. So I'm going to take negative 2 plus 1 over negative 2 plus 1 plus 6. If I try to do this with the power rule, there's going to be a problem. I'm going to add 1 and divide by it. And then plus c. Okay, ready? So I'm just using this power rule, which says I can add 1 to the current exponent and divide by it. So that's what I'm doing here. I'm taking x and add 1 to it. And this one is giving me division by 0. So here is where, if I have a negative 1 power, I can't do that power rule. It is going to be your natural log. So this is really your natural log, absolute value of x. All right, so let's write this up a little more formally. So my capital F of x is 5x to the, well, add that, and you get negative 1 over negative 1 plus 6 ln absolute value of x plus 3x to the negative 1/2 plus 1 is 1/2 over 1/2. And that just doesn't look good. I don't like fractions, and this can just be negative 5 x to the negative 1 plus 6 ln absolute value of x plus, if I divide by that, this becomes 6x to the 1/2 plus c. And that is good enough for me. You could write that as over x, and you could write that as square root of x, but that is simplified when you simplify each term. All right, so that is problem number 2. I'll be back for problem number 3.